So before we get into this, a couple things to review. A couple things to review before we get into the trig functions of any angle. First of all, what does SOHCAHTOA stand for? So you had SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And your tangent, opposite over adjacent. Okay? You agree?
Yeah.
All right. Now, the next part of this is that in order for us to be able to use SOHCAHTOA, what kind of a triangle did we have to have? A right triangle, correct. So here's what I want to do. Let's take an ordered pair. 3, 4. And what I'd like to do is take that ordered pair, and I want to plot it in a two-dimensional grid. Where does 3, 4 wind up? What quadrant? First quadrant, good. So you go over 3 and up 4. Do we agree? Now, what is the horizontal distance from the origin to that point? What was it? 3. The horizontal distance is 3. What's the vertical distance? 4. Now, what did we just create? We created a right triangle because our right angle is here. Now, what's the hypotenuse? I should figure that out so blindingly fast, lazily fast. It's a 3, 4, 5. Okay, good. So you wind up with 5 there, using Pythagorean theorem. All right, well, let's try this again. Let's plot -3 and 4. Same idea. Horizontal distance is how much? 3. Vertical distance is, what's the hypotenuse?
5.
All right. Even though my horizontal component was negative, the distance is still positive. Remember, distances are always positive. All right. At -3, -4, we are down in the third quadrant. Still have a hypotenuse of 5. And then lastly, just to fill it out, does everybody agree with that basic shape for those 4 quadrants, for those 4 points? Now, what I want you to see now, let's see if I can get this to work. For lack of better, for being pretty close. That 5 is a hypotenuse, and what else now, according to that circle? The radius, very good. It's also its radius. Everybody see that? Now, what's going to happen now is if you look at your unit circle, each one of these segments is the radius within the circle. Do you agree? Each one of those segments has an endpoint at the origin and on the circle. Well, what we're going to be able to calculate now is the actual endpoint. Once we know these endpoints, we're going to be able to calculate the radius, which in turn allows us to find the reference angles and all the trig functions at those points. That's the whole thing for today. So let's take a look at what's going on. We are going to be looking at what are called the 6 trig functions at any reference for any angle, at any coordinate. So, theta is going to be standard position of an angle. Remember, you have an initial side, that's always the x-axis. Theta comes up and around to the terminal side. That terminal side coincides to the hypotenuse of the right triangle that is formed with the ordered pairs x and y. So in our example, where I had 3 and 4, well, I'll use the kind of the same picture here. Let's say it's negative 3 and 4. Are we okay with that? We use negative 3 and 4? Bless you. That ordered pair was up here. We found that right triangle to be created. 3, 4, and the radius was pi. So given any ordered pair, you can find the radius, or hypotenuse for right now, and from that we can use the information and get every single trig function for that reference angle, for that theta. We may not know what theta is yet, but we can write out all the trig functions for it. Okay? So what we need to know here today is that the sign for any ordered pair xy, the radius can be found by using Pythagorean theorem, x squared plus y squared, and then take the square root of it. It's just a different way of writing out Pythagorean theorem, already solving for r. And every trig function, the sine of theta is y over r. Cosine of theta is x over r. And now these x and y's correspond to the ordered pairs. And then tangent of theta would be y over x. Okay. When I first learned about trig functions in terms of theta and ordered pairs like this, I always messed up my x's and my y's because we're so beaten over the head with sine, cosine, tangent in that order. Sine, cosine, tangent, sine, cosine, tangent. So as you're thinking that, you're always thinking your ordered pairs, x's and y's. So a lot of times people make the mistake of the sine value goes with the x coordinate. Well, that's wrong. What comes first in the alphabet, sine or cosine? Cosine. What comes first in the alphabet, x or y? X. Easiest way to remember what goes with what is cosine is your x value, sine is your y value. Okay? That's the easiest way to remember that. Make sense? Your inverse trig functions work the same way. All you have to do is just flip the fractions. So your cosecant of theta is r over y. Your secant of theta is r over x. And your cotangent of theta is x over y. One quick note to that. Why do they say that your x's and y's can't equal 0? Yeah, you can't divide by 0. So you can't divide by 0. Now, one thing I want you to think of, are there parts of the unit circle or parts of this where your x or your y value will equal 0? Yeah. What happens if you're on the x-axis? What's your y value? What happens if you're on the y-axis? Your x value is 0. So there will be times where your x values and your y values will be 0. That's why we told you guys not to find the cosine of 90 degrees. Because what's your x value at 90? It's 0. Okay? So it doesn't work. I can't find the tangent of 90 degrees because you're dividing by 0. That's why it's undefined. Okay? So what we can do now is we can take any ordered pair. Try to make this easy. (10 and 24). I can take that ordered pair, 10 and 24, and I can write out all 6 trig functions that occur at that triangle. So here's how we do that. Let me copy this on a separate sheet. So I'm giving you the ordered pairs 10 and 24. That's my x and the y value. What's the first thing you're going to solve for? R. So your r value is going to be the square root of 10 squared plus 24 squared. 26. So that means I now know what my x value is, my y value, and my r. So sine of theta is going to be 24 over 26. Oops, you write that as y over r, 24 over 26, which simplifies to be 12 over 13. Can't divide one by one number and another by another. Yes, ma'am?
What does the theta stand for again?
Theta stands for the angle that creates this. 10 and 24 is in the first quadrant. Do you agree? We'll just say it's up here. So what happens here is the theta value is this angle here. It's here. Okay.
But instead of using the angle versus the side.
Right, because we don't know what the angle is. We don't know what the angle is yet. But I do know that the side across from the angle is 24, and I know the hypotenuse is 26. So the sine of theta is 24 over 26. That's what that is. And what's going to happen is, as we go walking around here, we don't necessarily need to know what theta is right away, but we will start to figure out theta.
So theta can also be like a variable?
Yeah, and you can solve for that by using the inverse functions. Remember how you did that in geometry? Second sine of the fraction, it gives you the angle then? You've done that. You have done that. But right now, we're just looking at writing it in terms of the fraction amount. So cosine of theta is x over r. 10 over 26, otherwise known as 5 over 13. And then tangent. Was it 24 over 10?
Do you always want to have for all of them the same phase?
What's that?
The same theta? Do you want to try and have that? Or just...
What do you mean same? Well, you should have the same denominator for sine and cosine,
Okay.
because that's the same r value. And then you always just simplify your fractions. And then your inverse functions are just flipping the fractions around. And in this example here, it's going to be relatively simple to do because you don't have to worry about rationalizing anything. So your cosecant is 13 over 12. Secant is 13 over 5. Then your cotangent is 5 over 12. Is everybody okay with me just writing out the values? Since I know that the cosecant is r over y, and I just use the simplified term. Yes, sir?
If you want to find the degree, how would you make that degree?
Second sine, we have to be in this case you want to be in degrees.
Okay, just go like sine. If I put in like sine.
You have to hit second. You type second,
Okay.
sine, and then fraction 12 over 13, and then hit enter. And did you get 6738? That would be the angle measure.
Okay.
But remember, we're not really concerning ourselves so much with all of these angle measures. What we're going to worry about concerning ourselves with are going to be the main angle measures, 30, 45, 60s. Getting those sets of sines and cosine values because those are going to mirror each other all the way around the circle.
So every time you find the degree of the angle, you have to do that with the sine.
Yeah, but we're not doing that. All right, yeah. Okay. Not so bad. The only trick with this is going to come into play when you have to worry about an r value that gives you a square root. For example, I have an ordered pair of negative 12 and negative 15. I have an ordered pair of negative 12 and negative 15, so my x value is negative 12, my y value is negative 15. So the r value is going to be the square root of 12 squared plus 15 squared. Is everybody okay with me by writing out my r value without the negatives here? Do you guys know why I did that?
Because if you square it,
That's when you square it, the negative's going to go away. But how many times have you guys accidentally typed in your calculator negative 12 squared and got negative 144? Once or twice, maybe? Good chance?
Yeah.
Yeah. So just remember, what you're working on here is just the horizontal and vertical distance components. those will be positive, so just use positive value right away. So you get R value is going to be the square root of, what, 369?
Yeah.
That's not a perfect square, is it? No, but if you look at it, you can divide them both by 9, right? What's 36 divided by 9? 4. What's 9 divided by 9? So if you divide this out, you get 9 and a 41, so it's 3 root 41 is your R value. 369 divided by 9. So as you'll see, as you go for the sign value, it's y over r. So you get negative 15 over 3 root 41. Do radicals belong in the denominator? No, they belong locked up in an internment camp. No, I'm kidding. Radicals, get it? It was awful. That was but it was a good political reference there, right?
It was.
Good reference. So now, when you go to rationalize out your denominator, first thing you want to do is just simplify the fraction. What's negative 15 divided by 3? So I know that the sign is going to be negative 5 over root 41. When you rationalize that, what do you have to multiply top and bottom by? Root 41. And hopefully by now you guys are okay with rationalizing and being a little bit quicker at it. So your sign value is going to be negative 5 root 41 over 41. You're going to wind up having to do the same thing for cosines because you'll have a radical in the denominator. But one thing I will show you right now is if you had to find the cosecant is r over y. Well, r over y would be 3 root 41 over negative 5, or excuse me, negative 15. So that's negative root 41 over 5. You don't have to worry about rationalizing. Yes. You will see some of the quick patterns like that. But does that make sense how that works? Once you find your R value, then it's just a matter of substituting in the X, Y, and the R to figure it out from there. Yeah? Mm-hmm. Yes. I hope you do that. I hope you do that. Guys, what she's saying here is that before you get to the inverse part, once you see that this part here has been simplified, just flip it, there's your inverse, before you rationalize it. This part here? All I did was just taking that, the R value was 3 root 41, the Y value is negative 15, 3 over negative 15 is negative 5. That's all. When I get all the way over to the one side here, it just doesn't take it. Yeah, it's a bit. Come on, it's only March. You should have figured out my handwriting by now. Okay? Not so bad? Alright, let's get into referencing. Oh, I forgot. Quadrantals. These are my favorite.
Well, you sound happy as hell.
I do. Quadrantal.
It's like the
Did I spell that wrong? Quadrantal. Q-U-A. Quadrantal angles. Before I show off the whole part of it, let's walk through what they are and how you come up with them. The easiest way to talk about the quadrantal angles, well, what does the word quad stand for? How many of these do you think we're going to have? Boy, you guys are smart. SMRT. First thing I would do is I would draw an XY grid. Now, the first quadrantal angle occurs on the x-axis, we'll say about here. We're going to call that ordered pair 1, 0. Okay. At 1, 0, what is my angle measurement there? 0. Or Or 2 pi, sure. 360, 2 pi, sure. I was just seeing if you guys were figuring that out. Anyway, what is your x value? Your x value is 1. What's your y value? What's your r value? 1. Remember, your r value is found by x squared plus y squared. 1 squared plus 0 squared is 1. Square root of 1 is 1. Okay? There's my next one. At 0, 1. Now, what's my x value? What's y? And what's r? 1. Okay? Where do you think the next one is?
0, 0.
Wrong. -1 and 0. At 0, 0, it doesn't really give us, there's no distance there. There's no length. There's no triangle form. There's no circle. There's nothing. Oh, okay. So at -1 and 0, your x value is -1, your y value is 0, and your r value is how much? 1. So what happens here, these are your quadrantal angles. They are the ones that occur on the axes. They occur at basically 0, pi over 2, pi, and 3 pi over 2. For you guys, that means 90, 180, and 270. Hopefully you'll start thinking in terms of pi very soon. Now, what I want you to see is that we can still find the trig functions at all the quadrantal angles given x, y, and r. If I look at the first quadrantal, 0 and -1, the sine is y over r. 1 over 1, do you agree? The cosine is 0 over, or I'll write it out first, it's x over r, which is 0 over 1, otherwise known as 0. And then tangent, y over x, which is 1 over 0, otherwise known as undefined. Everybody okay with that? How would you find the inverses? Well, the inverse of sine is cosecant. So it's r over y, which is still 1 over 1. Inverse of cosine is secant, which is r over x, which is 1 over 0, which is undefined. And then cotangent. X over y is 0 over 1. So what you're able to do with these quadrantal angles is basically dealing with the stuff that we told you not to do last year in geometry. Remember how we always said don't find the sine, cosine, and tangent of 90 degrees? Because you didn't know what was your opposite, what was your adjacent, you didn't know which ones were which. It's the same idea of why you couldn't do that. Okay? But now we're saying you can. Because now we're giving you these ideas of the undefined and why this all works. And remember, the reason that we're able to do all of this is going to be because of this. As you start to see this, does everybody see on your, if you look at your unit circle that you have right now? Right now, you have no ordered pairs written on your unit circle. But we do know that here now, we can call that 1, 0, 0, 1, -1, and 0, and 0, -1. I would, because we're going to keep working off of that here pretty soon. We're not going to have enough time today to fill out the rest of our ordered pairs, but I just wanted to get us into the idea of what the quadrantals are. It kind of leads us into it. The last part of today deals with what are called reference angles. And the reference angles is a very important part in order for us to work with our unit circles. Because if you look at a unit circle,
Circle here.
Don't I have a copy of it somewhere? Sorry about that. Let me put this in real quick. If we look at the unit circle, just briefly, if we look at the unit circle, remember how we started this out? 30 degrees, 45, 60, 90, 120. If I'm here at 120 degrees, if I'm at 120 degrees, look at the angle directly to the, that shares the same y value. What angle shares the same y value with that? That was a 60 degree, right? So what happens here is that even though this 120 degree angle is not in the first quadrant, it's in the second quadrant, and its reference angle, the reference angle is going to be the angle, since this is in the second quadrant, going backwards to it. What's that angle then? 60. What we do to find reference angles, it depends upon what quadrant we lie in. A quadrant 2 reference angle. A quadrant 2 reference angle is always, always, always 180 minus whatever angle you're given. Right? It's always going to be 180 minus, we're going to call it theta, because that's going to be the angle we're given. If you think about that in terms of pi, what's 180 in radians? It's 1 pi. So it's the same thing as pi minus theta. That's how you get your reference angle. Go the same direction. Let's go to the third quadrant. If I take this guy here and I follow it all the way down, do you notice how they're on the same line here? Well, what do you think this reference angle is now? It's 60 again. Remember how we counted these down? We came down 30 degrees, down another 15, down another 15. So this was 30 degrees down. So, excuse me, 60 degrees down. So if you're in the third quadrant, the reference angle for the third quadrant is going to be whatever this angle is minus 180, because that allows you to bounce back up to here. Because you'll notice that these angles here and here are congruent. And they're congruent because what kind of angle pair relationship? Let's see, remember this one. Vertical angles, very good. You get vertical angles by going this route. So if your theta is in the third quadrant, you take theta minus 180 to figure out your reference angle. Same thing goes for in terms of pi. It would be theta minus, minus pi. Right. And then lastly, go to the fourth quadrant. You are in the fourth quadrant. Your reference angle, we'll use the same idea. We'll use that 60 again. So notice how I am boxing out the 60-degree angles so that they're all sharing the same kind of reference point here. If I'm going from here to come back up, how many degrees is that to get back to the another 60 degrees? So in order to figure out your reference angle for any theta that's in the third quadrant, it's 360 minus theta. Or in radians, what's 360 in radians? 2 pi, or 2 pi minus theta. That's how you're able to calculate reference angles. We use this little box idea to walk around our unit circle, because what you're going to notice, since these guys have the same horizontal component, their y values are the same. These guys have the same vertical component. Their x values are the same. These guys have the same y coordinate, or y values again, they're the same. These share the same x coordinates. That's how we're going to be able to take every 30, 45, and 60 degree angle within the unit circle and walk yourself around with reference angles. Okay? So a quick example. If I want to figure out what the reference angle, if theta is 110, what quadrant do I land in? Second quadrant. So the reference angle for an angle that's 110 is going to be 180 minus 110, which is 70. That's all you have to be able to do. You have to be able to figure out what quadrant it lies in and which one do you use. That's it. Okay? That's all I want you guys to be able to do for right now. Does that make sense? Works the same way if you're dealing with pi. If I say theta is 5 pi over 4, we have to figure out what quadrant will that lie in. Well, 5 pi over 4 is 1 pi and 1/4 pi. Do you agree? What quadrant would that be? Third quadrant. So to figure out the reference angle for 5 pi over 4, we take 5 pi over 4, and what do you subtract? We subtract pi. What are you left with? Remember, guys, when you're doing this, you have 5 pi over 4, subtract the pi. It's not going to be 5 over 4. Convert this to a fraction. Or use your calculator. 5/4 minus 1. Math, enter, enter. Because it's the same thing as 4 pi over 4. Get a common denominator, you're left with. There's your reference angle. Okay? What I want you guys to be able to do tonight is figure out what your R values are going to wind up being, given sets of ordered pairs, using the trig functions on quadrantals. I'm going to ask that you find a couple reference angles to start with today. We will build off of this tomorrow to fill out all of our ordered pairs on our unit circle. Because once we are able to fill out the ordered pairs on a unit circle, we don't need calculators anymore. I'm sure that makes you guys very happy. So what I'd like you to try for tonight is on page 7. I think it's 788. Is that right? You're on the right page there.
Yeah.
Page 788, I want you to do numbers 30 through 44 all. 788, 30 through 44 all. Okay?